In this video, we'll solve a few integrals involving trigonometric substitutions. So there are a few situations. If the integral contains a term of a squared minus x squared, where a is a constant, use the substitution x equals a sine of theta, where theta is between negative pi over 2 and pi over 2. You might recognize this condition from the function sine of x is restricted on the first and fourth quadrant, so that the inverse sign exists, and so that the function is 1-to-1, and so the inverse exists. And the useful identity that we'll end up getting is a squared minus a squared sine squared of theta. It's a squared cosine theta. Just imagine that you are factoring out a squared, so you get 1 minus sine squared of theta, which is cosine squared of theta. Another situation, it's a squared plus x squared, so the trigonometric substitution is going to be x equals a tangent of theta, and useful identity is a squared plus a squared tangent squared of theta. It's a squared secant squared of theta. And another situation is when the integral contains x squared minus a squared, and we use the substitution x equals a secant of theta, and we have the identity a squared secant squared of theta minus a squared equals a squared tangent squared of theta. So if we take a look at the examples that we see below, we have integral from 0 to 5 over 2 dx square root of 25 minus x squared. So 25 minus x squared would be this term here. The integral contains a squared minus x squared, so we expect the substitution to be x equals a sine of theta. So let's begin. So let's say x equals, well, our a, because we have 25 here, is going to be 5 sine of theta, right? So a sine of theta. Now dx, because when we do substitutions, we have to do the differentials as well. Dx is 5 cosine theta d theta. So the integral becomes integral of, instead of dx we put 5 cosine theta d theta, and the bottom is square root of 25 minus 25 sine squared of theta. This is going to be integral of 5 cosine theta d theta. If we factor out 25 from here, it's going to be outside 5, and then square root of 1 minus sine squared, which is cosine squared. Square root of that is going to be cosine of theta. Now, because our theta was restricted in these quadrants, if you remember, all students take calculus, means cosine is positive in these two quadrants, in quadrant 1 and quadrant 4. Because A stands for all trigonometric functions are positive, C stands for cosine, and secant are positive. Now, if we cancel this, we end up with integral of d theta, which is actually equal to theta, but theta is given by this relation, which means sine of theta, it's x over 5, or theta, it's arc sine, or sine to negative 1 of x over 5. So the answer is arc sine of x over 5, and x is from 0 to 5 over 2. So we get arc sine of 5 over 2 over 5, so it's like this, and then minus arc sine of 0. So arc sine of a half, where it's what angle, sine of what angle is a half, and the angle is in quadrant 1 and quadrant 4, well, it's pi over 6. And arc sine of 0 is 0. Now this problem, you actually learn how to solve this problem using formulas. We know that integral of dx over square root of a squared minus x squared, it's a formula. It's arc sine of x over a plus c. So we could have used that formula. But this is just a beginning of a problem to try to use trigonometric substitutions. Let's take a look at another problem. This problem here, has the term a squared plus x squared, right? I have a 25 plus x squared. So basically, in the table that we have here, we are looking for a squared plus x squared, and the substitution that we are expected to do is x equals a tangent of theta. So let's do that. X equals a tangent of theta. In our case, a is 5. So dx, it's 5 times tangent of theta prime is secant squared of theta d theta. So this integral becomes 25 tangent squared of theta over, now this quantity from the bottom, it's 25 plus x squared 25 tangent squared of theta, and using trigonometric identities, this is 25 times 1 plus tangent squared of theta is, well, tangent squared is sine squared over cosine squared, right? So if we get the same denominator, we get 1 over cosine squared, so it's 25 secant squared of theta. So at the bottom we get 25, so this quantity is 25 secant squared of theta, everything squared, and then times dx. The dx was calculated here, so it's 5 secant squared of theta d theta. So how do we compute this? Well, 25 times 5, I can write 120, it's integral of 125 tangent squared of theta times secant squared of theta over 25 to the second, it's 625 secant squared of theta times secant squared of theta. I just wrote it like that. I could have written secant to the fourth, but I want to cancel them like this. This one cancels with this. So we get 1 over 5 integral of tangent squared of theta over secant squared of theta d theta. Let's transform this into sines and cosines. It's a little bit easier to see. So 1 over 5 integral tangent squared, it's sine squared of theta over cosine squared of theta. And secant squared, it's 1 over cosine. So it's times cosine squared of theta over 1. So what do we notice? This cancels and we get 1 over 5. And I'm going to use double angles. So sine squared of theta, it's actually, so cosine of 2x, it's 1 minus 2 sine squared of x. So sine squared of x, it's actually 1 over 2 minus 1 over 2 cosine of 2x. So in our case, it's 1 over 2 minus 1 over 2 cosine of 2 theta, d theta. So when we calculate this, we get 1 over 10 theta minus 1 over 10, and then integral of cosine of 2 theta is sine of 2 theta over 2, and now this gives us theta over 10 minus sine over 2 theta over 20. Well, our initial problem was in x, so we want to move it back into x. Now, we started with x being 5 tangent of theta. That means tangent of theta is x over 5. That means theta is tangent to negative 1 of x over 5. So in this case, it's going to give us 1 over 10 tangent to negative 1 of x over 5. This would be theta over 10, is this one. And now, I have minus 1 over 20, and we have sine of 2 theta, which is, in terms of cosine, so sine of 2 tangent to negative 1, that would be weird. So because of this, I'm going to draw a triangle, and here is theta, draw a right triangle, and this relation tells us that tangent of theta, this one, tangent of theta, is x over 5. Well, tangent is opposite over adjacent. So in our case, opposite is x and adjacent is 5, which means the hypotenuse is x squared plus 25, which means if I have to write sine of theta, I'm going to write opposite over x squared plus 25. Now in our case we have sine of 2 theta. And we know from trig that sine of 2 theta is 2 sine of theta cosine theta. So in our case it's going to be times, so I'm replacing this piece. I already used the 20. 2 sine of theta, but sine of theta is, well, yeah, 2 times sine of theta, but sine of theta is x over square root of x squared plus 25 times cosine of theta. Well, cosine of theta, it's the adjacent side over the hypotenuse. So times 5 over square root of x squared plus 25. So I can do a little bit of math here and get 1 over 10 arctangent of x over 5, right? Tangent to negative 1 or arctangent is the same thing. 2 times 5 is 10, so divide by this is 2. So minus a half x over x squared plus 25, because square root times square root is no more square roots, plus c. I hope this helped. Let's take a look at the next problem. Evaluate integral of dx over x squared plus 6x plus 18. When we see this, we try to complete the square. So we have dx over x squared plus 6x. Now, if we divide 6 by 2 and we square, we know that we'll need a 9 here. But the problem had plus 18, so then I'm going to add one more 9. What does this mean? It means this trinomial here, it's x plus 3 squared, and then plus a 9. So what do we do in this case? Well, let's use substitution. So u equals x plus 3. And du is going to be dx. So our integral now is going to be, let me clean this up. Our integral now is going to be du over u squared plus 9. So now we see that this relation from the bottom, it's actually one of the trigonometric substitutions. And the trigonometric substitution was a squared plus x squared. And we used x equals a tangent of theta. So in our case, is going to be u equals, so let's do another substitution, u equals 3 tangent of theta. So du is going to be 3 times secant squared of theta, that's tangent prime, d theta. So this equation becomes, or this integral becomes 3 secant squared of theta d theta over u squared plus 9, that would be 9 tangent squared of theta plus 9. So 3 secant squared of theta over, we factor out 9, and tangent squared of theta plus 1, it's actually equal to sine over cosine, and so it's secant squared of theta. Right, I just replace this with sine squared over cosine squared, and plus 1, bring the same denominator and so on. Secant squared of theta, d theta. So this cancels, and we end up with 1 over 3 theta, but plus c. But theta was given by this relation. So tangent of theta, it's u over 3. So then theta, it's arctangent of u over 3. So then it's arctangent of u over 3 plus c. But u was x over 3, so we go back through all the substitutions. So x plus 3 over 3 plus c, final answer.